the long course of 2 months course that we are running. This is the several years that we are running these kind of courses. So always try to keep your microphone mute when you are in, and there is any problem right at your end, we will try to follow up with the request of your with your request. So I'm Giuseppe Amatulli. I'm running this workshop from already several years, pushing behind the level of the computation each time of the year. So it's getting even more and more difficult to engage all the different student and trainers also, due to that is an emerging field that is growing constantly. And in the last years, the last 3 years more or less, we start to add in the machine learning to the job computation package in order to keep updated with the speed of data processing and knowledge in the process, earth data process in this field. So as I mentioned to you, the course is running from several years, and we have been with very huge mailing list coming from the different courses that we have been running. And this is the geographical distribution of the affiliation, the country of origin, also yourself. And if you're scrolling down, you can see all the photo of yourself. I think is the only way that we have to have a bit of more personal feeling rather than not completely virtual. So that's why I ask you to upload the photo. In this way we can associate the name to the image, and maybe later on in June, yeah, we will wish to meet you, or you guys, in Matera if it's possible. Let's see, and I will briefly mention about this later on. So with me, they are going to teach also Shen, that is a collaborator from several years, and also Antonio Fonseca, that is also collaborating with me in different projects from several years. Tushar will be in the background for running operation in the, let's say, in the logistic, and also in the email requirement and voice, as you already see. So I will briefly talk about the learning objective of the course, and then we will do a little roundabout about you and presenting yourself, and also the same for Antonio. Um, so let's see, this course is going to cover it up as several aspects in the learning, mainly tools in GIS, remote sensing, and modeling in machine learning applied to environmental science. Okay. We are going to use mainly command line as been requested to the mailing list. So it's going to be 95% command line, just let's say graphical user GUI, graphical user interface for see what we are producing. That's it, only for this. The course is going to start with a general introduction of the tools for geocomputation, and that are preparing the background, the layers, the raster layer or the vector layer, for later on entering in the modeling and the machine learning procedure. So it's going to be a slowly transition from the geocomputation to the modeling, simple modeling, and then machine learning procedure. The main goal is really to develop your processing skills for the big massive data operation. Okay, so the requirement of the course was already to have GIS and remote sensing background. In few words, pixel resolution, projection, overlay, data acquisition, and all this terminology and knowledge about GIS need to be in your background. Plus, we also ask to have a Python background, an intermediate, basic intermediate Python background. In a few words, Antonio is going to cover it up, which one are the requirements. So the first five lectures is going to be mainly on Bash. So if you have let's say some not strong knowledge, not intermediate knowledge in Python, you can asking Antonio, Lonzo, and me to which one you can proceed along. Um, Something that also we push it a lot, and also this is something that the skill of Lonzo is they try to push your critical thinking and your learning activity for problem solving in the environmental space and in the geocomputation. Um, in the end of the course, you should be able to use proficiently different command line procedure between Bash and Python, and also to mastering your decision when you're going to use it, which kind of technique you are going to use it for the modeling procedure. We are going to touch different course, the different environmental study case. From the science perspective, from the environmental science perspective, they are going to be quite easy to do it, because then we concentrated in the machine learning, so in the math, in the statistic behind, and also in the data process. Okay, so we are trying to focus on this main area. So this is the typical curve that probably you guys have been facing, like us, when you start to learning open source software and coding in the environmental science. So most of you probably have already passed this peak. So you are in this very steep slope where you do the command line, but you are jumping to you facing the problem of run requirement and massive data process and all this kind of. So it is the steep curve that we try to speed up to bring you in this kind of point, advanced level, where later on you feel comfortable to say, okay, I never did it, but if I read, I can do it. So this is the kind of level that we want to reach with these kind of courses. Um, so we are going to cover spatial temporal analysis, the spatial temporal data integration to be able to combine different resolution in time and in space in the so-called data cube or data array cube for the temporal analysis. Some analysis of geostatistics, then later on would be used to understanding the machine learning in the context of environment application in the geographical context. Um, so the main software that we are going to use are mainly this one, with some other that can appear if there is a request or if there is some opportunity. So it is going to be GRASS and QGIS for the QGIS mainly for the geographic information system for the visualization, and GRASS also for some operation. We can see if you can do by a video lecture, or we can have a full lecture from my side. We can decide together. A Python for the GIS and raster modeling, and mainly for the machine learning operation. The Linux Bash really for the Bash programming. That is something that is very useful, and maybe it's not very well known for people coming directly from Python. But it's very powerful when you enter in the process of HPC computation. Okay, so over there is where you can really use the power of the Bash language and then call it to the different software. And then Oka, that even if it's a long, very old script programming language, but it's still one of the fastest for text manipulation and so on. And then we will have the GDAL OGRPK tools that they will be really the master king of massive data process in this aspect. So maybe we can start around about with covering up these main point among all of you. We start with Antonio Nellozu, and then Tushar, and then we start as a roundabout among you guys that you are presenting. Okay. So Antonio, if you can say something, few words about it.
Yeah, of course. Yeah. So I'm gonna try to follow your suggested list here.
Perfect.
So my name is
Yeah.
Antonio Fonseca, as Pepe already pointed it out. My background, I have been like trained as an engineer, but recently I have been shifting my interest to neuroscience. So my PhD is in neuroscience, although like I did microelectronics for masters and robotics for my undergrad. My general interest is with respect to modeling brain dynamics and how perhaps that can inform us with respect to intentions of an individual or how that might be implementing consciousness. I know those are all big words, but like if you're more interested on this type of research, let me know and we can discuss further. What else? Do you have an experience on Linux? Or yeah, I do everything basically on Unix based operational system, right? Although I use Mac, but essentially the Unix base is the same. Do you currently use any programming language? I live and breathe Python. So like that's basically all that I do. I know other programming languages as well, but like I don't use that often. What are your interests and expectations in this training? Wow, my expectation is that I can clearly communicate machine learning to you guys and that hopefully you can make good use of it. So you can apply to your own research and like move forward, like move the boundaries of your own fields. So that's basically it, I guess.
Thank you very much, Antonio. So Lonzo, a few words about you.
Hey guys, really glad to see everyone. My name is Shen. I'm from China. My background actually was in quantum chemistry. I trained to study chemistry system based on quantum mechanics. Then I met Giuseppe when I work at Yale and get introduced in the field of GIS and spatial modeling. And that sparked my interest because to me, geoscience is nothing else but the science about space and time. So we'll talk about that when we come to my part. Do I have some experience with, yeah, I'm a Unix enthusiast. So I have experience in different operating systems. If you have this particular subject, we can talk about that. Programming languages, I do programming with different languages. I start from C, then it's actually I know a little bit about Fortran, there's old day scientific languages. And gradually you have Python, R, Mathematica, different options. I don't have a particular favor here. I'm actually coding for mathematical purpose. So you will see when I get to math section, my personality a little more. Expectations, yeah, I will leave that for when it comes to my part. That's it. Enjoy, everyone.
Thank you, Lonzo. Tushar, a few words.
Hi, everybody. I'm Tushar Sethi. I'm a co-director of spatial ecology with Giuseppe. My background is in environmental engineering. Within that field, I have a specialization in waste and water management, and I help with the applied aspect of the research that we do as a group. And I also have a background in finance because before environmental engineering, I worked in finance, and so that helps run these operations with spatial ecology and with our commercial entity as well. So I'll pass it back on to Giuseppe.
Thank you, Tushar. So we are trying to follow these the student roster. Maybe Gulinal, you can start to say a few words about you. And sorry if I make mistake the pronunciation. So repeat, please.
Yeah, it's Gülnihal. It's no problem. You can say whatever you want. It's okay. It's Gülnihal. I already said that. I'm from Turkey. I am a PhD student in Çukurova University Landscape Architecture Department, and I am also working as a project assistant in GIS and remote sensing laboratory. So my background mainly focusing on ecosystem services, monitoring and managing. So we are mainly working on monitoring the natural disasters, maybe like erosion, landslides, And also, as I said before, ecosystem services, we are monitoring net productivity, net primary productivity, soil organic carbon. I'm usually working with this. So my final project, PhD thesis, is focusing on like crop yield production. What my aim is to, with this training is, I just wanted to feel confident about using machine learning and coding about my GIS and remote sensing analysis. So let's jump this in. I do not have any experience or Linux, unfortunately. But I am using programming languages like Python and a little bit of R, maybe. Yeah, that's all. Thank you.
Yeah, thank you, Gulina. So we pass to Janusz, I think from Poland.
Okay, so hey everyone, I hope that you can hear me. I'm Janusz Godziak from Poland, from southern Poland. I'm also a PhD student from the University of Silesia. My background, it is mainly digital evaluation models analysis, some geomorphology, and also GIS analysis of historical maps, especially in case of forest ranges, how the forest ranges were changing during time. And I did those analyses for Polish mountains, for Polish Carpathians. And my PhD project is also focused on a little bit on forests because it is about, especially about wind throws, about the damages of forests caused by hurricane winds, and how it influences also how it influences the forest, the slope microtopography, and also where such the question about this, where such forest disturbances occur, and also connection with meteorological data and analyzing the wind regimes. And my experience, right now I'm mostly working in R environment. Some time ago I worked in Python, so I have some background, and I have a little experience with Linux, but mainly still working on Windows. And expectations, maybe to increase some programmistic skills, to learn new software, and to improve skills mainly in big data analysis. Thank you.
Okay, thank you very much, Janusz. Yeah, try to be short. Rosa, for you, that we are, I think, 20 kilometers away from each other.
Rosa, I don't think we can hear you. I'm not sure if others can. I can't hear you.
I can't either.
Not either.
Okay, meantime that you fix the microphone, we go to Sebastian. Is Sebastian there? Can't see all of you guys. No. Eric, yes, because I saw you.
Eric, you're on mute.
Okay, also Eric, we know that he's there, so he will present later on. We go to Giske from Norway.
Yes, hello.
Okay,
My name is Giske.
This is
I'm
from Ghana.
working at the University of
My background is
Bergen.
software engineering and a little of data management, and
Okay.
I'm a Greek open
we'll let Eric finish and then we'll go back to Gitska.
Yes, Eric, you can
And
continue.
please, can you hear?
Yes. Yes, please go ahead, Eric.
Sorry, my network is very bad here in Ghana.
Yes, just go on, take out the screen.
If you turn your camera off, Eric, it might help you. If you turn your camera off while you speak, it might help with the connection. Yeah.
Okay. So my name is Eric Jurado Kumabaku, and then my background is software engineering. I did data management as well, and I'm into open data. I'm an activist for open data, especially in Ghana. I work on Ghana Open Data Initiative for some years, and then I had my master's in software engineering. I did a little of data analysis, and then I have a knowledge and a little experience in Linux, but not very good because during my studies, I need to touch all these things, and I have Python background as well, but not expert in it. I am interested in this course because of the idea of machine learning. After my master's, I must look at where it is applicable. So when I saw your special course on with machine learning, I found it very so interesting, as my interest is also in agri-business. So that actually pushed me to come over or to register as one of you. So I'm glad I'm here to learn from my seniors, my master, PhD holders and stuff. I'm so grateful to be here. Thank you so much.
Okay, thank you, Eric. So we go back to Gisk.
Hi, can you hear me?
Yes.
Yeah.
Hello?
Hello?
Okay.
Can somebody hear me, please? Yeah.
Am I supposed to go on now or? Okay, my name is Giska and I'm an associate professor at the University of Bergen in the Department of Geography. I'm having a background from ecology, botanical ecology. So my personal interests are land use, land cover change, species distribution modeling, remote sensing, time series analysis, and yeah, related stuff. I'm not sure exactly what I will look at in this course, but I have some ideas. I have some experience with Unix a long time ago, but lately I haven't used it that much. I've been using QGIS, GRASS, and R. So I have some R knowledge, but not, I've been using Python a little bit, but not too much. Yeah, and I'm very much looking forward to learn all these open source tools and more about machine learning. Thank you.
Thank you very much, Gisk. And then from Spain, Tommy.
Hello, you hear me?
Yes, microphone very low.
It's very low. It's better this way.
Okay, perfect. Go ahead.
Okay, sorry. Yes, my name is Chomin. I know it's a little bit strange the way it is written, but it's a Basque name. Not very usual in Spain, but I have a geographical background. I did my PhD in physical geography, trying to understand the differences between different statistical modelings for landslide susceptibility. And now I'm working in the same direction as a postdoc currently in Italy. I'm in the research center of CNR, in Italy at Perugia. So yes, I in the last years I worked very much with the Linux computer. Actually, my current computer is a Linux one, is an Ubuntu. But and I have known here and there all these programming languages like R, Python, Bash, also in Grass, like as a kind of language, programming language. But I mean, I am still in the very basic level, and what I'm expecting with this course, it's really, I'm looking forward to rise up in this learning curve and not go to my colleagues each time I have errors. That's it.
Gracias, John. Yes, we know this problem in the beginning that we go to the colleague. We did also. So,
Yes.
So we are trying to push that level a bit high. And then we go to Sebastian. Sebastian here.
Yeah, can everybody hear me?
Perfect, yeah.
Okay, so my name's Sebastian. I'm a PhD student at Brown University. My background is in hydrogeology, and I'm getting my PhD in geochemistry. And I'm really interested in how watershed and landscape characteristics impact weathering and carbon fluxes. And so kind of the course of my PhD, I'm going to be pairing geochemistry with geospatial analysis. And that's kind of the reason I'm here. And so I have, I work in Python. And I think the big thing I'm getting out of this course, wanting to get out of this course, is that I spend, I program in Python, and then I do a lot of GIS analysis just using the GUI. And sometimes I get frustrated because it feels clunky after doing programming to be using the GUI so much. And so I really want to make that more efficient and waste less of my time in the GUI and just use the efficiency of the Python coding. So I'm really excited to learn that in this class.
Perfect. We are going to see many of these command line for graphical command line for raster and vector process. Very good, thank you. Miriam from Copenhagen.
Yes, hi everyone. I'm Miriam Marundin, and I'm
Miriam,
yes.
so your volume very low. Increase a bit.
Yes, thank you very much. Can you hear me now?
No, very low.
Yeah, it's still.
Or if not, try to shout a bit.
Okay, yeah, I'm going to try to speak up louder. So I'm Miriam Marunding, and I'm coming from Switzerland, and I just finished my PhD actually in economics at in Copenhagen, and I'm going to do a postdoc now, moving to Portugal. And so I'm coming with a economics background, looking mostly at applied micro, and I have a focus on development economics in Africa. And in my postdoc, I'm going to look at particularly water, like river modeling around the world. So I'm hoping also to use this course to enhance my knowledge on that end. So I do have an extensive knowledge on R, also work with Python and QGIS, but I think it's all from a, like it's all self-taught and from an economics kind of background. So I'm really looking forward to get some professional, environmental aspects that fit into this. And experience in Linux, well, I mean, when I was little, my big brother put me on Ubuntu, but back then I didn't really get the excitement of it. And now that I'm going back to it, or kind of set up the virtual machine already, like I'm really looking forward to get back into it. And beyond that, programming language would be R. And I do have a big interest in open data as well. And I think interest and expectations, I really would like to become much more efficient in big data handling. As of now, I think it's lots of going around and do some small fixes. So that would be one thing, and clearly get leveling up my whole skills in that sense. Thank you.
Thank you, Miriam. So we move to Vincent from Canada, but working in the United States.
Hi, everyone. My name is Vince. I'm a professor of marine remote sensing and geospatial analysis at the University of Florida. And I'm originally from Quebec, the French-speaking part of Canada. I was initially trained in geomatics, so GIS, remote sensing, cartography, spatial analysis, but now I really focus on seafloor mapping and modeling, and habitat mapping and species distribution modeling. I don't really have an idea for a project yet, although currently I'm trying to look into deep sea coral modeling in the Gulf of Mexico. So that might be something interesting to explore. I don't have a lot of experience in Linux, actually not at all. And in terms of open source software, I've been using QGIS and also R. I use Python as my main programming language, and I'm getting more and more familiar with R. And my expectation of this training, basically, as a professor, I do a lot of project management and I work with a lot of students, but they are the one getting the skills and I slowly get behind. So my goal for this course is really to kind of catch up and get up to date on what's state of the art in geocomputation. So, thanks.
Yeah, thank you, Vincent. We will push the boundary as you request. Laura, that from when she's not in the forest catching mountain lion, she's with us. Colleague.
Hey everybody, I'm really excited to be here. I'm Lauren Satterfield. I'm from the University of Washington in Seattle in the USA. My background is in wildlife biology, wildlife ecology. And so I'm really interested in species distribution modeling. I'm interested in climate change ecology, fire ecology, time series analysis in relation to animal movements and survival and those sorts of things. So I'm doing my PhD right now. I'm a PhD student towards the end of my degree, looking at how recolonizing wolves are affecting cougars and then what that means for their shared prey of deer and elk in Eastern Washington. So that's kind of what I'm focusing on right now. But I want to do larger spatial ecology projects going forward. You know, I'm interested in becoming a spatial ecologist as my career path. So that's why I'm in this course. I want to be able to work with larger data sets. I don't have experience in Linux. I code mostly in R. I've done a little bit of Bash, and I've never used a Linux system. So I think like I'm excited about that. But yeah, like I was saying, I have a little bit of experience in Python, but not much. And so I'm hoping to build that with this course. And really, I would like to come out of this with the ability to take a large spatial data set and you know, be able to manipulate it into a strong analysis. Somebody asked me if the puma is my pet. No, but we colored this one in Montana. So
yeah, nice. Thank you, Lara. And by the way, here, if you are really in, there are several study cases for species distribution modeling that you can already jump on it on this one. And then we have one representative, Young from South Korea. Thank you for, I think it's really the night over there.
Yeah, it's overnight already.
So thanks for the effort.
Thank you for the giving me a chance to learn geocomputational. So my name is Hae-young Shin. My background is sociology. I'm a PhD candidate of environmental planning at Seoul National University in South Korea. I'm mainly focused on identifying the impact of climate change and environment pollution to society. So now, as a PhD thesis, I'm focused on the anthropogenic air pollutants like carbon dioxide emissions inventories for South Korea. And I little bit of experience R and Python for my research, but I don't have any experience with Linux. So I'm so excited to have a chance to improve geocomputation and machine learning in Linux. Thank you.
Thank you very much. So we pass to Hemala.
Hi everyone, my name is Hemalata. You can all call me Hema. So I'm originally from India and studying in the US, as Laura mentioned, from the University of Washington, Seattle, in the School of Environmental and Forest Sciences. So I have a background in like combination of biotechnology, environmental science, and environmental policy. So I'm currently a PhD student, and my interests are mostly in land classification model and how to improve like environmental impact and life cycle assessment using those land classification model. And yeah, I have a little bit of experience in Python and R. And for the GIS tools, I have experience in ArcGIS, but not that much in QGIS, and absolutely no experience in Linux. So yeah, these are the programming languages I currently use, mostly Python and R. And the expectations for this class is like, so I did like a land classification model, like a supervised model using Google Earth Engine on like a smaller area, but I really want to scale up to like more regional level, like national level. And I believe like this course would equip me to do like such big data analysis. So that's why I'm here. So nice to meet you all.
Yeah, perfect. Thank you, Emma. Yeah, we will address in also this kind of application. Yes.
Hello, I'm Ritvika Mukhopadhyay, originally from India. I'm presently a doctoral student in the Swedish University of Agricultural Sciences, Sweden. And my background is in forestry and geoinformatics. And presently I'm working on, for my PhD projects, I'm working on estimation of above ground biomass predictions using remote sensing data and field data, and the modeling and the associated uncertainties I try to estimate in different frameworks, as in model assisted, model based, and also hybrid inference frameworks. So I don't have any previous experience in Linux, but I started exploring a little bit here and there. And previous programming languages, I presently use R and Python mostly. And expectations from this course would be to be more efficient in handling the geospatial data and manipulation of the data.
Thank you, Ricky. Use the work in Germany.
Hello, everyone. My name is Jusdiel. I come from Cuba, but now I'm based in Germany doing a postdoc in the Leibniz Institute of Freshwater Ecology and Inland Fisheries and the Technical University of Braunschweig. My background is related with systematics biology, conservation biology, and evolutionary biology in general. But my present postdoctoral project is about conservation planning of freshwater ecosystems across Cuba, taking into account the distribution of freshwater biodiversity and also ecosystem services. My experience with Linux, well, is very basic. The programming language if I have experience is R, and my expectation with the course is to first improve my abilities with Linux, and also learn how to use another languages like Python or R.
Perfect. Thank you very much, Hilda. So we move to Maria, also from IGB, Germany.
Yes, hello. Can you hear me?
Yeah, perfect. Yeah,
okay.
Go ahead.
So my name is Maria Magdalena, but everybody calls me by my nickname Marlene. I'm from Austria, and my background is in freshwater ecology. I'm currently working as a PhD student at the Leibniz Institute of Freshwater Ecology and Fisheries in Berlin, Germany, in the same working group as you Steele and also Aphrodite and Jaime, which are also participating in this course. My PhD is in the field of spatial conservation planning, and I'm currently working on identifying fine-scale patterns of environmentally unique freshwater habitats. And for this, I'm implementing k-means cluster analysis. Yes, I have experience in this Linux, so I also have Linux on my computer. Yeah, I use a lot of R, so I think my R knowledge is more advanced, and also a little bit of Bash. Yeah, during this course, I hope to improve my programming skills and also get a little bit faster in using cheetahs or pickle tools.
Perfect, Norman. Thank you very much. Now to Aphrodite from Greece.
Can you hear me?
Oops, your picture didn't show up. I will fix it.
No problem. So hi, I'm Aphrodite from Greece. I'm also doing my PhD in Berlin. My background is in biology and then ecology. And now in my PhD, I'm interested in special patterns of aquatic insect distributions. So actually I have a global data set of aquatic insect occurrences, and I want to build special species distribution models. And so I work on Linux, on Ubuntu every day, and I use mainly R and Bash, and also Grass, GDAL, and PK tools. I've used Python, but only to solve small problems in courses, not for any project of mine, or to understand scripts in Grass, for example. So my expectations from the training are I would like to be able to handle all this big spatial data and decide which machine learning method is best for my data, and to build such big models. That's all.
Yeah, thank you very much, Aphrodite. And ahora Colombia, Jaime, a ti.
Yeah, hi everybody. My name is Jaime. I'm from Colombia, but also working in the same group in Germany in the Leibniz Institute for Freshwater Ecology. Sorry for the background noise. My son is playing the drums and he didn't care about the meeting, my meeting. I'm an ecologist and dedicated some years on conservation. So applying optimization techniques to find out the best areas for conservation of biodiversity, and that involved a lot of spatial data, pre-processing, analysis, also applying distribution models, and testing different models, different scales. Also did some analysis on land cover change, and so on. The last 3 years I dedicated to data analysis, spatial data analysis. So I've been learning a lot from Giuseppe, basically using large data and using Bash programming. Yeah, and I'm interested in coming back to some modeling some environmental phenomena, and that's why my interest in how to use Python techniques to take this data we are processing to do some more modeling, focus on ecosystem services and so on. So I have experience on Linux. I think I'm fit at this point using Linux and the command line. And that's it. Thank you. Looking forward.
Gracias, Jaime. Thank you. Erin, you know each other. Go for the students.
Yes, we do. Hi, everyone. My name is Erin Stearns. I'm a spatial epidemiologist based in Seattle right now. I am not working on a PhD or anything currently. I'm working for myself, primarily doing consulting and contracting with different organizations and research entities. And I actually took Giuseppe's course in 2018 on geocomputation, and that was focused on using open source tools where you might have used something proprietary in the past. So I'm just going to admit it. I'm familiar with these things. I am not going to be ahead of anyone though, probably. So just being transparent there. But yeah, I do run Ubuntu. I primarily code in R and do my analyses there. So one of my goals or objectives of taking this course is that, and Giuseppe knows this well, occasionally I get a problem or a challenge that I'm coming across, something like an optimization problem that, you know, basically for a whole country, can you help us decide where we could place a health center and have the biggest effect? And of course, that's an optimization problem. And using PK tools, that could run quite quickly. But if you use R, it could take days and you're probably going to need a virtual machine or something like that. So my goal is that it's kind of second nature, that I don't even think about the R option. I automatically think of these optimized ways of going about these analyses. Yeah, my interests, as I said, I'm an epidemiologist, so my interests are in diseases, but I actually also am very interested in sharks and shark epidemiology. So we'll see what my final project ends up looking like.
Yeah, thank you, excited to hear it also.
Yeah.
And now we go to more to the east side. Hamad is also another collaborator from our group. I don't know if he's joining or not. Can't see everybody. I don't know why I do that. Okay, and then we move to JD, another one. Let me up some photo. JD.
Yes, thank you, Giuseppe. Hi, everyone. Can you hear me?
Yeah.
Okay.
Perfect.
Great. My name's JD. I'm from the East Coast of the US, and I recently graduated with my bachelor's in biology and ecology. I'm primarily focused or primarily interested in species distribution modeling, and I'm hoping to basically just grow my skills in that nature. And I have some familiarity with a few programming languages like Linux, Python, and R from recent projects, but I'm hoping to build on what I've done in the past with Giuseppe and prepare for a graduate degree.
Thank you, JD. We go to Bethany.
Hi, sorry for not having my camera on the whole time. My internet's not the best here, so I didn't want to be dropping out. But yeah, I'm Beth. I'm from Scotland. I'm currently working for the James Hutton Institute as a research assistant. And as part of that, I'm doing quite a lot of GIS analyst stuff as well. I come from a physical geography background where I was initially really interested in glaciology. But after my master's in GIS and remote sensing, I've turned my interest to land use observations and ecosystem services. And that's increasingly related to climate change and creating tools for policymakers here in Scotland. I have previously used Linux machines in the past for quite a lot of remote sensing processes using Python libraries. But now I heavily focus on using R and GRASS within the terminal for processing and modeling tasks. But I'm increasingly using Bash and Python alongside this as well. And yeah, I'm really looking forward to expanding my experience in a variety of software and building on the skills I gained during my master's degree.
Thank you very much, Beth. We'll try to achieve all what you mentioned. And now, Hamidres, also from that area, from Ireland, close by. I don't think. Yes. No. Okay. So now we go to China. Wang.
Hello guys, my name's Yuan Chen and I'm from China. I'm a fourth year undergraduate from Peking University and where I'm majoring in environmental science. And I'm going to start my PhD at MIT this fall to work on something to use advanced statistical models to analyze environmental data and climate data, where I'm using like remote sensing, satellite imaging, and atmospheric models. And clearly, I don't know my PhD thesis yet. And previously, I worked about industrial ammonia emissions, like plant level ammonia emissions during my undergraduate. And yes, I have some experience on Linux. I used atmospheric transport models like geoscam to model the atmosphere. And I also used some Python and R languages. And for this course, I'm excited about this course, and I'm going to learn this course to be prepared for my PhD. And yeah, that's all. Thank you.
Thank you very much, Ivan. Now in Mexico, con Alonso.
Hello everyone. Thanks, Giuseppe. I'm Alonso Gonzalez. I live in Mexico City. For the past 7 years, I've been running analysis in GIS, and I want to move those analysis into the programming environment because I think it's more efficient. I'm interested in forest sciences and also urbanism. So I'm in the first stages of programming. I'm in the learning curve. I've also tried a couple of times, but I think this is the good try to learn how to program and use GIS. Thank you.
Perfect. And then we go to Matt.
Hey, thanks very much, everyone. Matt Hallis here. I'm a geospatial consultant working out of Colorado in the US. My background is a lot of remote sensing, so multispectral, hyperspectral analysis. I'm also not actively pursuing any sort of master's or PhD. This is simply to kind of assist in the work that I do, which is supporting a lot of global organizations. Oftentimes it's focused basically on things like global health problems, humanitarian problems. One of the projects I'm supporting is actually working with currently Giuseppe Tushar and Aaron. We're doing some really cool kind of, well, more so the Margosa team is doing some really cool environmental modeling that I'd like to understand kind of how that actually gets done. My experience with programming languages is more limited, a good bit of Python, but definitely not an advanced level user. So a lot of more user interface based work with NV and ARC and QGIS. So I'm really excited to understand how to better use programming languages kind of in the context of large geospatial data analysis, and hopefully devise some interesting project that I have not yet thought about. So excited to be here. Thanks, y'all.
Thank you, Matt. So we will cover up both this point. So now we try to go back to someone who didn't speak, like Rosa.
Can you hear me?
Yes, now yes.
Oh,
go ahead. Cool.
Thank you. I'm Rosa. I'm a PhD student in geosciences at the University of Bari, South Italy, but now I am in Arizona for a very short period as a PhD visiting student. And my work is focused on monitoring flood events through the analysis of a large amount of satellite images, especially Sentinel-1, so SAR images. Okay. And I'm trying to calculate trend analysis and so on. I have a little experience in Linux, but I have experience in Rust, QGIS, MATLAB, and Python. So thank you all so much.
Okay, thank you very much, Rosa. And someone else is missing, didn't able to talk before? Okay, good. I think we covered up all of them, all of you guys. So the geographic distribution is well done. I missed a few photo in this in the roster. So if you didn't send, please send me, and also specify. I think I remember all your nationality, and but in case I miss it, just
does Ahmed Shah want to say something? Ahmed Shah, we haven't heard from you yet. Would you like to introduce yourself?
You are in mute, I'm sure. Okay, maybe some connection problem. Anyone else? Okay, so we can move. We can slightly move to the next step. So in terms of coding, you see that some of you, most of you know already R and Python with a sort of level close to the intermediate, maybe even advanced level, but just few people are fluent in, let's say, the GNU Bash and Linux operating system. And this is, as I mentioned before, they're really critical skills, especially when you want to do the language integration and be able to combine that's it, the language integration, to be able to combine different technique in according to which language you want to use it for the different data process. So we are going to touch, as I mentioned, different command line over here. We will see also how to achieve parallel processing in Bash, and also Antonio will cover it up for the TensorFlow or the machine learning analysis. The machine learning will be really focused not only from the, let's say, from the application point of view, but also the mathematical and theoretical background. So feel free to bunch Antonio and Lonzo of questioning this subject. They're really experienced knowledge. We will see mainly supervised regression, and maybe Antonio will also touch some classification application. Regression is a bit more understandable. We focus last year. We teach the classification, so it was not was a bit more hard for the students. So we shifted to the regression problem, but there are already material for the classification. And we will touch mainly image processing, raster processing for GIS analysis, and of course we can't work in really large data, because I mean, we are working in a virtual machine. So, but the technique that we are implementing and use it are very useful for the large data. So the shift after the courses in working in high performance computing will be just 1 week of learning how to use and actually we have already also video tutorial where we teach how to use the high performance computing using these tools. And we will see some environment application, hydrology, forestry, and some other, as I mentioned, very simple from the environmental application, but more complex from the math statistical process, and also from the computational process. Let's see how we are going to see the syllabus and how we are going to work. So our main platform is going to be this one, spatial ecology, the docs. So I've been sending the link, so you can arrive directly in the spatial ecology every time that you click on the site over here, on the logo. You are going to the main one, and then over here is going to be our landing page for the course. Okay, so you click over here and you can find mainly the class roster that we were running through just before, and the preliminary syllabus. Preliminary syllabus that if you open, it's going to open the program in now. Okay, like this because I didn't enlarge. But anyway, so we are going to cover it up. So the first 5 lectures are already well set up, and then in according to how we progress and how you follow it up, we can try to shift a bit to the other parts. Okay, so every time pay attention, especially for people that will not be able to attending. Every time that we do a lecture, we are going to list over here. So below final over here, they're going to list the final syllabus that we really run with the video recording, and the same for today. And this is happening usually after a few hours, because the recording is still running in the Zoom account, and then it's processed, and then I put a link. So you can feel free to watch later on. So these are the main goal that we are going to use it. We are going to use it GitHub for the repository, and they are going to be a little review by Lonzu next time. But anyway, it was on the video, and we will address it together with the virtual machine. We're going to use it community support with Slack, that everybody join so we are, feel free to text us for some problem and so on. So what we expect from you guys in terms of hours of working in this course. So we can range a bit like between 10 hours and 20 hours among you to catch up with the skills that we explain and that we present every week, you know. The beauty of that, you can really apply this technique directly to your data set. Okay, so we are not the homework, there will be a sort of suggestion homework, but then you can present in something really similar, let's say, or maybe even different, but with the same kind of level of effort with your PhD data or your master or whatever you want to use it. So this is really helping you to really focus on the course meantime you are doing your PhD. So feel free to use other technique, feel free to use other data set, because if I have to say, okay, try to make a mosaic of all this image, rather you do it NNDVI calculation between 20 image is the same, is fine for us. So we are not really strict to the assignment. So this is very important, this kind of skills that we are trying to teach you guys for the reproducibility of the research flow. Okay, so in the code in the clicking procedure, so what you do it usually, you really do it step by step without even linking back all the steps. So you do a bit of raw data image analysis, climate data analysis, and so on. Then you do gathering, cleaning, filtering, and every time you do another clicking procedure, you know. Then you pass to the statistical physical analysis, and you're ending up with graphics. So we try to have one common flow between here to there with different software, but all the software they will be able to do and talking to each other. Over there is where we really you really pass the next step of so-called language integration. So you can using bashers or gluing for calling R function or Python function or other way around. So this is where you're really able to mastering the processing the language for the master data process. And the beauty of this is that you can really do this language integration and library use when you're working under Linux. Under other software, under other operating system as a Windows, they are working, but they are not really fluently working. Mac is fine because on the background it's a Unix system, so it's going to be a really easy transition for people using Mac. And why we really use it, as you see among you guys, some of you already use it, Linux, because it's very light, it's very secure, it can be interoperable with different different operating systems. So Graphs can be built under Windows, can be built under Mac, and so on. The application, there are thousands of free software, and we will see how to search in the virtual machine, how to search for new software. There is a really low minimal hardware requirement, a RAM requirement. So all the, let's say, the operating system, Linux operating system, using a very small amount of RAM. So you have the leftover for your data process over there. There is free, so you can use it without any license constraint, and it is fun in the sort of way. Okay, and why is fun? Because this is something that we try always to stress with Lonzu, that we are not just helping you to click a button, but start to think what to do, and the coding is helping because you have to make an effort to really find the right tools in order to, or the right library in order to perform that technique. The help that you will going to have from the mailing list is amazing. The Graphs mailing list and the R mailing list are all of them, probably some of you already use it. They're really helpful, and there are people reply directly to the question, or there are plenty of tutorial and manual. You can really understand how the computer works. You can really understanding the process, the job priority, RAM priority, how to manage quite well the RAM. And also with your laptop, you can really achieve much more computation capability rather than not using clicking procedure. You can also working to server. Now I'm running everything with my mobile. We are in Zoom through my mobile. I can log in into the Yale cluster, for example, for running geocomputation stuff. So it's something that really years ago was not possible, but now it's very easy to have this freedom. And this you can do it because you are using the command line. Try to do this one with the graphical user interface be in Italy from a mobile, very, very difficult. Hardware resources is also important, that you can really compress the file, understanding very well how to structure the folder structure and so on, and organize very well the process. Also, something very important, enjoy the life, maintain the PC is working for you. So really creating the scripting procedure during the day, let it run during the night, and the day after see the result, adjusting, and so on. These skills are really promising for doing this kind of massive computation. This massive computation that can be done, let's say, in three different main ways. So according to the different people, we can have three main ways. The one that we are going to use it is to have, let's say, the bash, like the Linux as a central core, from where we call all the different tools. So GDAL and or Field Toolbox for remote sensing analysis, QGIS for a bit of graphical user interface, Oak for text manipulation, Python also for text manipulation and machine learning, and so on. R statistical also for machine learning and plotting procedure and so on. So in Bash can be really the main core of the analysis. Nowadays, there is also another trend is to have R in the center, or even Python in the center. And then from Python, you call the other software and so on. So this one is mainly, I would say, for people that are working more in Windows, so they don't have really the Bash user interface, the Bash terminal line. Even if now also in Windows there is the Bash command line that you can call it. But feel free to use whatever you are most comfortable. We will focus mostly in this one. And sometimes that's why we started also with Bash, for later on migrate to the Python and so on. We are going to use the virtual machine that we have been using. You guys have been following the instruction to use it. We are not going to use today, but we are going to handling next on Thursday with the Bash terminal, in the Bash terminal, for the use of Bash terminal. And our system to operate is going to be the Jupyter Notebook, Jupyter Lab or Jupyter Notebook. They're very similar. And Lunzu is going to explain how to install it. Actually, I think he's already installed it in the virtual machine. And these are the main tools that we are going to use. So far, this is the general overview of the class and how we are going to operate and so on. So in terms of class organization, we are going to have more or less like is going to cover it up, this stuff, a bit of overview in the beginning, and then overview of the lecture, question, and so on. 50 minutes, 1 hour of class, then 15 minutes break, and then another 40 minutes, 45 minutes of class again. And we are going to try to combine always a bit of theoretical background with the coding and so on. And now I would say let's open the floor if you have some question, and then we can have a little break. And then I will pass the floor to Antonio, to Lunzu, that they are going to present their part. So, but feel free to raise your hand if you have any question concerning this point. Now we can go in. Sorry, some people were chatting in the chat. Okay. Okay, nothing important. So no question. So I would say let's go in a meeting. Sorry, in a break. So we come back at 30. Okay. So whatever is time at 30, we're back. Okay. Perfect. I will pause the recording and then. Okay. Cool. No. I think I cannot pause.
Antonio, can you do the pause? Giuseppe is signed in as a guest for some reason.
Okay, yeah, I can do the pause.
You know, I log in correctly, so.
I already started.
Okay, cool. And then Lorenzo is back. Okay, main time that we are waiting for Lonzu. So I think Sebastian was missing before from the general interaction, isn't it? So you want to say a few words about you?
Hi, yeah, I was not able to join the first hour. I'm Sebastian from Berlin, Germany, from Freie Universität. I'm working in the field of planetary science, and I'm using many of the tools already, but yeah, I want to learn even more, I guess. That's my intention.
Thank you, Sebastian. And okay, so Lonzu, we can give you the floor.
All right, cool. So what should I go first? Just go to my section directly? Anything else? All right, cool. I will start by sharing my screen. Let's try this works. 1 second. Can you guys see my screen?
Yes.
Yes, perfect. Yeah.
All right, perfect. Thanks so much. First of all, let me say a few words about myself. I'm honored to be a guest speaker for this training series. It's really good to see everyone. I see the title suggests I will lead the spatial statistical part of this lecture. And this particular time is meant to be introduction. It's about something of you and something of me. So I'll begin with your side. So I look at your questionnaire. You already performed prior to class. I look at this expertise that from the questionnaire. I was astonished by the huge diversity we have here in this group. Now you see that some fonts are bigger than others. It doesn't mean a particular individual is bigger than others, but they are set up in such a way the number of response corresponding to that particular expertise getting bigger, we have a higher number of responses. So primarily we see, we have most geographers, ecologists, environmental scientists, and maybe some biologists. In particular, the technical aspect, I concern the mathematical capacity because I will do the spatial statistical part. I look at this one, it's a fairly nice distribution, I would say. I think everything else looks fine, just the confidence intervals maybe need a little boosted. So that's going to be the task I'm going to do for my lecture. So, okay, this is about me, my plan for the section I'm going to lead. I observe from the questionnaires, we have a huge diversity in the classroom. And somebody come from economics, somebody come from biology, some are from other hydrology, spatial epidemiology. It's a very diverse and heterogeneous background. I see the enthusiasm, people with a lot of passion, with energy from your introductions, so that you want to learn, you want to get something out of the class. I see the motivations and also see at the same time the challenges. So how can I do my best to organize an effective section so that everybody can get something out of this class? Well, one possibility, and I think we also discussed about that, is you look at distribution. So I suppose this is a distribution everybody can recognize, which I want to represent. If you don't recognize this as a distribution, I think we have a little issue. If that's the case, we can talk about it. And you can argue whether it is normal or not, but I just use normal distribution as a representation. So one possibility or actually suggestion will be, you just look at distribution of people and take the one in the mean and just, hold the class from that particular point and just move the class, based on the pace and the engagement for that particular point. I thought about this, but I actually don't like so much because I actually want to reject this kind of philosophy because it's not concerning everyone. So nobody's a statistic here. So everybody come here to the class, make a commitment, and everybody counts. So this approach I want to do is I care and I think you matter. You're living, you occupy space, and you have mass, and you matter. So I want everyone to get something out of this class. My strategy and my plan is to do the maximization, to maximize the potential of each individual in the classroom and your capacity to gain from beyond where you are. So it won't be ignored because you know a little more about eigenvalue problems. And it also won't be ignored if you don't know the gradient of a scalar field. So I'm trying to organize this material so that everybody can take something out of this class. And I believe the limit of your potential is infinite. It's going to be my regret that my limitation will curb your development. So I will prepare the best material I can assemble, organize, so that push you to the upfront of the spatial statistics. The way to do it, I will begin with a question. So I want to ask, what is the aspiration? I see a lot of people here are scientists, like researchers, professors, others maybe doing consulting or business. I just ask for a general, high-level, broad question about your aspiration of your career. Because we are limited here by the time and interactions, I just want you to type one word or two words in the chat box so that I can see what you want. Can somebody do that right now? Able to do that right now? I hope I can see the reaction from the chat box. So let's say, for example, I say publication. It's my aspiration. I want to do research. I come here to publish. Anybody else want to put something over there? Just 1 or 2 words. Yeah, I see optimization. Anything else? Learn, okay. Mastery, all right. Improving, yes, of course. Yeah. So yes, mastery, I see again. I just made a great mastery of technical skills. Yeah, fantastic. So I see a lot of mastery, all right. Okay, so I think we are bound by time. For those who haven't got a chance to speak, you get a chance to speak later. Yeah, independence. Yes, I like that one. You have more time to do that. So at the moment, I will just turn back to my presentation. And solving problem, yes. Filling gaps in knowledge, that's fantastic. Yes, all right. I think I pre-anticipated many of this. So if you look at my presentation, I think everybody says great things, but I think they are more or less related to several aspects, at least here. So you want to make explorations, you want to make discoveries, you want to master skills, but the ultimate goal of mastering skills is to generate solutions. And you want to sell your solutions in certain ways, and that through some persuasion. You have to tell the audience that your solution is a good solution, and also in some instances, you have defined your solutions. So this course, the material I want to organize is to offer the tools for you to have the skills on all these 5 aspects. So let's begin with a simple one. This is a real case. It's about a reviewer comment for our paper, which I did together with Giuseppe and others in the audience here. So I'll just let you to read, maybe 2 seconds. I want to ask you if you have any reactions from these comments, because this is one particular instance for self-defense. You have to defend your work. So you get this kind of criticism, and you want to ask, what would you do? What it means? So if somebody wants to say something, I'm happy to. I think people can speak, right? If they take out the mute from their speaker.
To unmute themselves, yeah.
Yeah, if you want to speak, just speak loud. I'll leave here. You can still see. Anyone want to volunteer to speak? That's fine. If you don't, I will go ahead. I just gave like a 20 seconds something to react if somebody wants to say something regarding to the comments. So this is about the thinking process. So my lecture or my part of this course is focusing thinking process. All right. So let me cut off. Okay. So let's just do this. All right. I strongly ask you to do a k-fold cross-validation, because RF, random forest, is a particular machine learning algorithm. It's a strong data-driven approach. K-fold cross-validation is needed for avoiding overfitting of the RF model. Correlation coefficient is not sufficiently secured with only one split process. So I'm not asking you about any context of work. I'm just asking you about the analysis of the logic of this comment. All right. When I saw this, I don't really care, anything about what has been done. So the comment is about the need for avoiding overfitting. But everybody knows cross-validation, right? Cross-validation is just a way to assess the model. It's not preventing the overfitting or underfitting. If that thing happens already in there, it won't be prevented through this cross-validation. That's number one. Number two, correlation coefficient, doesn't matter which one you use, is not sufficiently secured with only one splitting process. Well, this implies this one is not good, but is there a particular coefficient is sufficiently secured with one splitting process? So this is the kind of thinking I want to introduce to you. Apparently, this comment itself is full of logic knots. What do you do? Well, Einstein said, the wise people ignore. If you like these kind of examples, I will introduce a book to you. Actually, this book was not my discovery, was introduced by one of my colleagues who is a geographer anyway, because people say every geographer is a philosopher. So this book is about the logic of scientific discovery. I think many of you here are doing science, being a student or researcher, you want to make scientific discoveries. And this book is telling you or discuss with you why there is a logic in scientific discovery. The author of this book is Karl Popper. He's a very influential philosopher, especially in the spatial domain. This whole setup of spatial epidemiology was based on the Popperian philosophical approach. And in this particular book, the chapter starts with the problem of induction. Does anybody can tell me what is a method of induction? Just use one sentence. How do you say what is induction in scientific approach? What does induction means? What's the inductive method of analysis approach in scientific settings? Anybody want to say something? All right, so induction, to put in simple words, is basically just generalized from a singular or a few observations. That's so-called induction. For example, before people have seen the black swans, it was a common belief all the swans were white. And that's inductive approach. People generalize saying all the swans should be white until they meet the black one, which is totally overthrown the previous assumptions. So why this example is so far-reaching? Because in real life, no matter how many instances you have encountered, you're running a risk if you generalize without any deductive thinking, just to build your conclusion based on several or singular observations. So that kind of something I'm trying to approach I'm trying to avoid. The approach I want to take is to give you a method. The method is generally applicable. You need some changes, tweaks to apply to a particular domain. You can transfer from economy to epidemiology to forestry to hydrology, but you have to make some change. But the general framework for the method is applicable. I will provide some provocative cases. That means these cases are designed with help you to think, especially how to facilitate to think the logics. And the entire structure of the mic section will have inherent logic from the pedagogical perspective, because we are running a course, not a summer school. So this is not a course about recipe books. You can take a piece of things and just run it. It's about training of chefs. So I provide all the techniques and knowledge to you so that you can cook your own things in your own way. It's not coding centric. You're welcome to code in Python, in R, in Java, in Scalar, in whatever language you like. But the key is on the innovative thinking. And the center is on the ability to solve problems. So what do I mean by solving problems? I give you a real life example that happened in 1968. Well, there's a submarine that got lost on the way going back to the home base. And people have to search for this particular submarine in a vast area in the Atlantic Ocean. The task was very challenging because there's no knowledge about why the marine was sunk and where it was sunk. If this question came to you, a real life question, do you have some idea to start with? But anyway, does anybody know this question already? Anybody already heard about the story? I don't think I can keep track this, because I'm going back forth and between full screen and now I'm trying to check the chat box. Nobody respond. All right. Okay, so let me just get back. This is not meant to be a test or anything. So this problem was actually solved with the simple idea. It's called Bayesian optimization. I won't go into the technical details. The point I'm going to make is this is a real life example with people with the knowledge of modeling to help identify a solution. It was a very successful case. And I think you see where I'm going to. In order to do so, we need to do some common languages, because somebody speaks biology, somebody speaks geology, somebody speaks epidemiology, and we have to somehow communicate between each other. The language choice, I think, is obvious. As Galileo said, is the mathematics. The reason to do that is the mathematics is actually essentially to make things simpler and clear. So I hope by the end of the class, you'll be able and feel more comfortable to speak this language. It's not going to be something we accumulate the knowledge or testing the outcome of a particular case studies. It's about your capacity and the directional thinking based on the mathematics. It's about when you are doing research or doing a particular problem that you are in the midst of the forest without sense of direction. And the mathematics will be the light to guide you outside the forest, give you the solution. And I hope by the end of this class, if you haven't spoken so much with mathematics, you'll be more fluent. And if you're already fluent, I think you'll like it better. And hopefully you also, like me, better by the end of the class. Do I get some emotion on that already? I think we have some options on this Zoom. There's a reaction option. There's something there. You can raise some reactions if you like. And also, what's the policy, Giuseppe? If people like me, can I share my bank account? People can transfer something to me already.
I don't think you will get anything.
Okay, yeah. So let's keep on track. Let's keep on track. So all right. So no bank transfer. All right. But at least that's my intention. So to this end, I have some asks. So I want to ask feedback. I want to have engagement from you. I want to build this course to be interactive. So achieve the best.
Just for the group to know, Longzhu has a very dry sense of humor.
I'm sorry?
I was just advising the group as to your dry sense of humor.
Okay, it was funny or not?
Oh, that was
All
a
right.
joke. I already transferred some money.
Oh, I didn't give you my bank account though. Be careful, it's different from spiritual ecology. Thanks. Yeah. So I want to ask feedbacks. I want to be interactive in this class to achieve the best outcomes. That's why, feel free to interrupt me during any process of my lecture or talks. There are emotions from the Zoom. You can also open up your speaker anytime you want. Yeah, that's one to say. And this course is total free. It's not command and control. You don't have to do anything you don't want to do, homework, whatever. Everything is total voluntary. It's totally free will. That's always what I want to advocate. But I ask you to do your duty. So my duty is going to be put my best effort with the best material I can assemble and organize to present with my best capability to explain the things I want to explain. What I want to ask you to do is to overlay your ambition over your perspiration and keep cracking and keep growing. Let's build a live community. It's a community that we can exchange ideas, share experience. Just keep in mind, Rome was not built in a day. Let's have this community to have this continuous learning process and make this learning process more joyful in our collective effort. Ultimately, I hope by the end of the day, maybe 5 years down the road, you come back and look what happened in the past. You can be proud that you carried your passion to you and you connect dots. And that concludes my lecture today. Thanks for your attention. Should somebody want to say something for now, I'm happy to take questions. Let me just take out the sharing right now. If not, I will just go to this chat box. I think there's a URL already shared by Antonio. And I'm going to also take advantage of this opportunity to turn over the section to Antonio and he will help you to do some fun activities together regarding to math session and move on to sections. Thanks, everyone.
Thank you very much, Longzu. Pepe, can I just jump right into it, or you want to say anything?
No, go ahead. Go ahead. Yes, please.
All right, so I'm going to share my screen. Okay, can you guys see my slides properly?
Yes.
Hear me okay? Yeah, okay, great. So let me move this window out of the way. Okay. Yeah, so as we discussed in the beginning, right, I'm going to be covering with you guys the machine learning part, more specifically the artificial neural networks part. Of course, if you're talking about machine learning, for those who are also susceptible to be bombarded by the media, there is a lot of like big words like deep learning out there, right? And inside of deep learning, there are many different branches, right? And for example, for all that matters, random forest, logistic regression, even PCA, there are all types of learning, right? But as I said, like I'm gonna focus particularly on this flavor of deep learning, which is the artificial neural networks, right? Now, with respect to like where machine learning is in our lives, like well, I'm sure that you have heard of like, for example, self-driving cars, right? I see that there is a message there. Okay, yeah. And for example, we have smart devices nowadays that are capable of collecting information of your body and even estimate when someone is about to have a heart attack, right? So like there is machine learning pretty much everywhere in our lives nowadays. But for this course in particular, we are going to focus on things that are closer to geocomputation, right? So like we're going to use mainly like data sets that have geographic base, right? Some of them, for example, have satellite images, which are quite popular, right? So like here, just few of these applications. So for example, this method that these guys developed to identify swimming pools, right? And map like where the houses for potentially like places where they should pay attention in order to prevent like a outbreak of Aedes aegypti, which is like the mosquito that's responsible for dengue, chikungunya, which is a big deal back in Brazil where I'm from. So like you see that like machine learning can be very helpful for public health, right? And also like in order to make sure that the society is going the direction that's supposed to be. So like, of course, there is also the dark side of machine learning, which like, yeah, our cell phones nowadays are constantly collecting data from us, right? But the way how they sell it is that basically that's to make your life easier, right? So your device learns about you and help you with your daily tasks, right? Another very popular application for like machine learning geography is basically mapping, right? So Google Maps is one of them. But essentially what you do is you do a survey of all the streets and like what are the condition of those streets. And that's the sort of thing that nowadays is done in a collaborative fashion as well. For the people who care more about forestry, for example, there is this very cool paper, which I forgot to put the reference here, where basically what they do is to do a plot for like the diversity of trees that you have in California, right? And they generate this beautiful image that basically looks like a painting to me. So you can see like that there is a degree of like organization in the types of, in the way how these trees, they are arranged, right? In the forests in California. And besides having the knowledge of how the distribution of these different species of trees is taking place, that could be also informative for preventing forest fires, for example, right? So like you could design a plan that could potentially contain or prevent the progress of a wide forest fire, which like for the ones that are not in US, that's a huge issue that we have in California and has been going on for many years now due to like climate change and so on, okay? So perhaps one question that's like is still in your mind after my introduction earlier today was that I'm a neuroscientist, right? So like, why is a neuroscientist trying to teach you anything, right? But I don't have a background in geography or like geocomputation at all. but you're gonna see that like our fields, they overlap quite a bit, okay? And for that, I'm gonna tell you a little bit about like how machine learning, more specifically artificial neural networks, they started, right? So here what you see is basically the frequency of the word, like neural networks throughout time, right? And what you see is that like machine learning, although we have this impression that machine learning is something that's new, right? Let me just see if I can change my cursor here very quickly. Can you guys see the laser pointer?
Yes.
Excellent. Yeah, great. Yeah, so you're gonna see that like the word machine learning per se, right, is something new, but it's had different names throughout history, right? So for example, neural networks and connectives, those are the first words that were used to describe machine learning, right? And they date back to what they called initially biological learning theory, right? Which is like from Hobbes, right? Which some of you may have heard of it, which is like in the brain, neurons that fire together, they connect together, right? So that's basically saying that like things that they seem to show a high degree of correlation or relationship between them, usually they might be informative, like when you're trying to understand how one impacts on the other, right? So it's an extremely logical sentence, right? That's like we take for granted, but something that like was characterized and studied in the 50s as being biological learning theory, right? From that, they developed something that could reproduce the kind of behavior that we saw in neurons, right? And they call that the perceptron, which basically stands for like a single neuron, how a single neuron might be able to solve mathematical problems, right? And we're gonna see that like in a bit. But funny enough, the word neural networks per se only picked up like in the 80s, right? And why was that? The effect was that like with the perceptron, which was the first element of neural networks, right? Which like for all that matters is just emulating a single neuron, right? The problem was that the perceptron per se was very limited with respect to what types of tasks it could solve. And throughout the lectures, we're gonna see like what the perceptron is good for and what are its limitations and why we had the need for having deeper and more perceptrons, right? And what does it stand? What does it mean? When I say that I need more perceptrons, now each layer is composed by several perceptrons and I have several layers. And that's why we say that now it's a network because it's composed by several perceptrons, right? So it's a neuron, it's a network of neurons, it's a network of perceptrons, right? And it's deep because I have several layers, okay? And we're gonna understand exactly like how we scale from like this single unity, right? The single neuron to something that's deeper, right? But like several problems are gonna arise in this like process here, right? And we're gonna walk you through the process of solving each one of these problems, okay? But as I was saying, so like backpropagation, which is this very famous technique for training deep neuronal networks, came in the 80s. And that's basically solve all the problems that the perceptron had, right? So now we are capable of assembling these very complex networks of artificial neurons, right? And they are extremely capable of solving very complicated tasks, okay? Like in some of these tasks we're gonna cover, which like Pepe and Lugs already mentioned before, some of these very useful tasks are classification and regression, right? So given a specific type of data, we're capable of like making some predictions on that. Very well. The word deep learning, that's the one that's like this very sexy word that everyone loves to talk about. It's quite recent indeed, but you see that the principles are the same and we basically have been changing the name of the cow throughout the time, but the cow is exactly the same, okay? Very well. So like I have been telling you about this perceptron, right? So what is the perceptron and how does it actually represent what a neuron does, right? So for those that are not familiar, here on the left, it's an actual neuron, okay? So the neuron has like some fundamental components to it. So like we have the dendrites, which are the parts that are responsible for like sensing difference in electric charge, right? Basically like difference of concentration of ions outside of the neuron. We have the nucleus, After all, the neuron is also a cell, so you still have the nucleus in there. Then we have this very long extension, which we call the axon, right? Which basically broadcasts the information that was processed by the neuron, right? So like here you see that you have the inputs, right? Then this information is processed somehow, which I'm not going to get into the merits of that at this point. Then after this processing takes place, we broadcast that information to the end, okay? So now if we can break down each one of these elements that I briefly described to you here, basically what we have, it's a series of inputs, right? So like for all that matters, we can say that like each dendrite that the neuron had can be emulated as a single input, right? So here you see X1, X2, X3, Xn, right? Each one of them might be weighted, right? So what does it mean? Some of these dendrites, they might be thicker. So like they might be more sensitive to the electric charge that were detected by that specific dendrite, right? So the inputs, each one of these inputs that are being given to the neuron, they matter in different scales, right? After you do some operation, which here, like we're simply saying that's a sum, right? You might say that you want that neuron to fire or not firing, right? So like, let's say that the output has to be binary, right? Or it could be just like a linear mapping, right? So something that's proportional to the inputs that are given. And then you give an output, right? For those of you who are familiar with statistics, probably you're looking at this now and say, this looks a lot like something that I have seen before, right? And you're definitely correct. And that's something that we're going to discuss throughout the lectures as well. Very well. So, of course, this is supposed to be like emulating a single neuron, right? But like, of course, this doesn't really cover the whole story. There are several components of how a single neuron actually works that's missing from this model of the perception here. But for all that matters, like that's not really like what we need to care about. But like just for curiosity, it does emulate some aspects of how the brain behaves, right? So for example, we do see in some experiments that are also from these periods, from the 60s to 70s, that the neurons of a cat, for example, they do respond differently to the type of stimulus that's being presented. So like in a simple stimulus where you have like some bars, right? The angle of those bars matter in the active of some neurons are tuned to the type of angle, to the angle that this bar had, right? So you see that there is some sort of weighted average of what's the stimuli, right? In order for these neurons to be active. So like for simple response of like some specific regions of the brain, the perception does a good job, right? But when you go to other areas of the brain, you see that actually you have a pretty large hierarchical dependence between like different stages of the visual cortex, right? And to address this type of like hierarchical limitations that we saw with the perception is that they developed something that basically inspires convolutional neuronal networks, right? Which are extremely popular models nowadays that were also based on observations done by neuroscientists, okay? So you see that like all these fancy machine learning, more particularly like neuronal networks methods, they did came from inspirations of neuroscience, although it's very debatable if they actually emulate anything that looks like the brain. Very well. So at this point, as I mentioned before, right, basically what the perception is doing is basically a weighted average of the inputs, right? And what's the goal of the perception basically is to find those weights that in an appropriate fashion combines the inputs that you're receiving in order to give you an output that gets as close as possible to your prediction, right? So like that could be the angle of your stimulus, right? Could be, for example, if you're giving the as input some conditions about like, let's say, some conditions about latitude, longitude, elevation, and you're trying to predict the rain, right? You might be interested in finding the weights or the appropriate way of combining these inputs in order for you to get as close as possible to an accurate estimate of the likelihood of rainfall, for example, right? But moving from this, which we said that was highly limited, very limited, right? to something that now we have several neurons, just like the one that we're looking at right here, right? We have several neurons. And each one of these neurons, instead of going straight to a model that could combine this information, right? Now we have like intermediary layers. So basically what it does is to not just find a weighted average of the inputs, but also what's the relationship between those inputs, right? So like that's what essentially what these hidden layers they do. And that gives us way more flexibility, right? And that's why machine learning became such a big word. It was solved by backpropagation, right? So that was the moment when neural networks really caught up to like be what is nowadays. But you see that like the challenging of actually training those monsters, it's real, right? Because before what you had was like, okay, so I have this input, I change a little bit the weight, and then I can see directly how that impacts on my output. Now, if you change one weight here, you have so many other interactions that are happening to the weighted input, right? That's very difficult for you to estimate if that small change is going to get you any closer to where you want to be. And that's why backpropagation really changed the game, okay? And throughout the lectures, you're also going to understand what is backpropagation and why is it so efficient, and how we can make use of it. Very well. So among the types of machine learning, right, we can break machine learning into these three main branches. Some of them are very familiar to you. So for example, from the side of supervised learning, we have classification and regression, right? We have these other two branches here that they are very important for machine learning in general, but unfortunately have limited amount of time. So I'm gonna discuss with you guys, right, throughout the lectures, mainly things that are coming from this section here, which like the classification, the regression, right? I'm pretty sure you're familiar with many of these approaches, right? So for example, we already heard about random forests today. Decision trees are also like from the same sort of flavor, right? Nearest neighbors, it's also very popular, right? So what makes a classification task a classification in the first place, right, is the assumption that you have labeled observations, right? So like you're gonna go from features or like predictors, like some people are more familiar with that expression, right? Associated to each observation, and each one of these observations, they have a class or a category, right? And basically what you're trying to do is to link those two. In the regression, you don't have a label, but rather you have like a real number that represents a quantity that you're more interested in like trying to model, right? So if you're talking about trees, for example, classification would be perhaps like what's the tree species, right? And a type of regression could be what's the tree height, right? Like what's the thickness of the trunk, right? So some of those, like here we just have like two applications where you could potentially fit these frameworks, right? But I'm pretty sure you can think of like other thousands of applications from your specific fields. And that's the beauty of neural networks, right? Because like the method is going to be exactly the same. And the application is very much up to you, because as long as you're able to provide inputs that are associated to like some observations, by inputs, I mean these predictors or like the features of the data, right? And a label, either like a real number, which would allow you to do like a regression, or a category or a class, which would allow you to do classification, you're capable to do absolutely anything, right? And that's why learning about neural networks is such a useful skill nowadays. Unfortunately, right, supervised learning, which is the part that we are gonna aim to cover like substantially in this course, it's just like the out layer, the outmost layer of the problem, right? Because it has a huge issue, which is the need for labeled data, right? So like, for example, imagine that if you're doing this survey for like tree heights, you do need the actual height of the trees for you to be able to model the system, right? So you do need a bunch of samples, right? of like trees that are from different locations. They have like several features that are associated to them and their respective heights. So you can build such a model to do this prediction. And that's not cheap, right? Because then you have to deploy a team to go out there, like collect all this information, right? So it's extremely difficult to actually deploy large-scale supervised learning approach, like in the industry in general, right? So like the comparison that Yann LeCun did in 2016, Yann LeCun, for those who are not familiar, he's the winner of what we would call like the Nobel Prize of Computer Science, right, in 2019. He says that like if we think of machine learning as a cake, supervised learning would be perhaps the icing, right? The reinforcement learning, which like we're not really gonna cover, but like reinforcement learning like is also trying to learn from the data by providing rewards. So you don't have like a label, you just let the machine to know if the machine is getting better, like in general, or worse, right? That would be like even smaller of a problem, which is like would be just like the cherry in the cake. And everything else, like the bulky part of machine learning, would be basically unsupervised learning, which you do have no knowledge of how the system is behaving. All you have is like features, right? And then you try to make sense of these features that you have in your hands, right? So most of the problems that you would find out there in the wild, I would say, they are essentially unsupervised, right? So hopefully, that's of course going to depend a lot on the progress of our classes, right? I can tell you a little bit of some of these unsupervised learning approach, like with respect to neuronal networks as well, right? Because like unsupervised learning, you have several other approaches that don't necessarily use neuronal networks, but that would be really cool. But of course, I'm not going to try to push it. The most important part is that you understand the supervised learning part very well, okay? Very well. So like in machine learning life cycle, right? Perhaps we can break it into like collecting the data, doing the pre-processing, training the model, testing the model, deploying that model that you train, and then just monitoring, right? Like luckily we have the data already, so we don't need to worry about that. Some of you even help to collect those data that we might want to use, right? So like this part is covered. The data processing that we are going to cover, like what are the usual steps in like organizing your data in the right way, how the training is going to take place, right? And for that, we're going to use Python a lot. So I hope we can get you all up to speed, even the ones that said that you are not entirely familiar with Python, but let's try to do our best. And how you test it, right? So what are the metrics that can help us to assess the accuracy or the efficiency of that model, right? So what are we going to use to implement those things, right? So of course, Python, right? But there are libraries that they are very handy with respect to implementing machine learning. Here, at least the three biggest ones, to my knowledge. Of course, there are several other libraries that are coming up now. So Keras is very popular, although it's very limited, so it doesn't really scale very well for large data sets. And because I don't want you to learn something that's already limited, like off the shelf, right? So like we're gonna mainly think of TensorFlow and PyTorch, okay? TensorFlow, it's excellent for high performance, right? So like I want to at least show you a couple of examples using TensorFlow because that's going to be very important and relevant for your career. But what you see is that in reality, PyTorch is way more popular nowadays, right? So like for the sake of having documentation and like finding resources for you to learn more about it, PyTorch is way better, okay? So I'm going to give more priority to PyTorch unless there is a very strong feeling with respect to like sticking to TensorFlow. But otherwise, for like pedagogical purposes, I would say that PyTorch is better, okay? All right, so now with respect to the expectations, right? I know that all of you already answered the questionnaire that Pepe sent to you all like a while ago, weeks and weeks ago. But what do we expect you to know, and so you can follow properly this part of the course, right? So how much familiarity you should have with respect to coding, right? I would say that you should be comfortable with Python, right? Because like, I'm gonna assume that you know how to operate things in Python. And then we're gonna build on that, which like how to use those library structure to implement machine learning. If you don't have, if you're not comfortable with Python, in the spatial ecology, there are 2 links there that are intro to Python, right? And then Pepe can redirect you to the proper resource in the web page, and how to use like, how to do operations there in general, right? So like, if you don't feel comfortable with Python, please go over those tutorials, all right? Knowledge of algorithms, that would be great. If you're already programming any other language, at least the logical components should be the same, right? So like, you can think in a logical way, and you're able to develop a code that does that. Because if you have logic, how to actually implement things is basically just ask Google, right? So you can say like, oh, I would like to do this thing that you usually do in R, but I would like to do in Python. Most likely you're gonna find the answer, okay? And if you're familiar with like some other techniques in general, even if they're not related to neuronal networks, for example, PCA, support vector machine regression, those are all very useful skills, but they're not really necessary, right? But that's gonna put you in a better place to understand the context. How much math do I have to know? Yeah, so this part is, I think it's very important, right? So for example, you should be up to your game with respect to linear algebra, right? So like matrix multiplication, right? Like you should be able to understand how to do a matrix multiplication. Eigenvectors and eigenvalues, I'm pretty sure Longzhu is gonna cover, right? Calculus, just the basics, like how to perform integral and derivative, right? Those are things that are gonna be important for you to understand how machine learning works, but how to use perhaps not that important. So like, let's say that these would be desirable, but not essential. Now, if there is any other thing that you're anxious about and you're not exactly sure if you have the requirements, please reach out, because we can always point you like towards an extra resource, right? Besides the one that we're gonna cover in class. Extra resource with respect to like a review in linear algebra, like how to go over like some fundamentals of Python, right? Which are gonna be very used here. So we can always redirect you like to the appropriate resource. But like, yeah, don't wait until the last minute to ask for that. So like, if you feel like you're gonna need help, like, or a refresher, please reach out as soon as possible, okay? And of course, you can always reach me like on Slack. I'm there. For those of you who are not on Slack yet, please do so, because I think that's the most efficient way of communicating with the class. Or you can always shoot me an email as well. Okay. And I think,
yeah,
oh, yeah.
Thanks, Antonio. Really helpful information that you give for the background in mathematics, statistics, and general understanding of machine learning. Yes, we open the floor to some potential question. Please feel free to speak now. So
in the meantime, meantime, you can already access that link that is sent to you guys in the chat and also on Zoom, okay? Because you're gonna have this quick quiz where we're gonna make a little assessment about where you guys stand with respect to some of the content that you're gonna cover throughout the course. So it's just like, while you think on your questions, and if you wanna ask something in the meantime, please already start going to that link. And if you have any issues, let me know.
Yeah, you can find a link in the Slack under the general channel.
And also on Zoom.
And also in Zoom in the chat. Yeah, I don't have it, but maybe.
Right, I sent earlier.
Okay.
All
so
right.
If you, yeah, so maybe no question about program. If you have a subject that we want to cover, you can ask some particular case. And so, for example, who has been using supervised regression or classification, let's say supervised model? I think I would say out.
And there's a question in the chat box.
Okay.
I already
chat,
answered. Yeah.
Yeah, my chat book. Not. Okay.
Maybe we can start the.
Perfect. Yeah, let's start the
Yeah.
quiz, because with the quiz we will see some answer coming out.
Yeah, I'm gonna go to the first question there, right?
So
So
do
the way
you-
how
do
it's
you-
gonna.
Do you have
Sorry?
the link? So just be sure that everybody has the link.
Yeah. Does everyone? Did everyone manage to get to the link that I sent? You should be seeing these at this point. Waiting for Antonio Oliveira Fonseca 958 presentation. Okay. Okay, so I see that some people managed to get there. Okay, so I'm gonna activate the first question. So now you should see this. Okay.
So you
So-
have to click.
Yeah, then you click on the option that you think is the correct one. So I can read the question out loud, okay? So the question is, if you build a linear model such as y equal to a plus bx, what will likely be the R2 for this data that is shown here? Unfortunately, it's a little small, but I can zoom in for you here, right? So you see that the y is the y-axis and the z is the x is the x-axis, right? So if you try to fit a linear model to this data, what is most likely the R squared that you're gonna get for any prediction that you make with that model? And then you click on the option that you think is the right one. I see that I already have 12, 13, 14 people already replied. How many people do we have here?
30.
30, okay. Should I wait a bit more to see if everyone managed to reply? Or should they just move on to see the answers? I can't hear you, Pepe.
Yeah, sorry. This is very important to understand. So they understand the level of the class, you know, and how far we have to we can build on top of it.
Right. And at this point, you feel free to say, I don't know. The
Yeah.
I don't know is always going to be there as an option. Okay. The goal is really to see like where you guys stand. The answers are anonymous, of course. Right. So like, I'm not going to be able to see who answered what. Right. So like, feel free to be very honest here on your answer. Okay. After appealing, I got a few more answers there. Okay. Just for the sake of time, I think I would just move on just to see the answers.
Yeah, 17 is fine. Yeah.
Okay.
Feel free to keep reply. Yeah.
Right. So we see that the majority of the people who answered, they said close to 0. Okay. Like the second most voted one would be 0.5. And the third most popular is the I don't know, which is fair, right? But I'm very glad to see that like people were between 0 and 0.5, right? The correct answer would be very close to 0, because as you can see, there is no way how you can fit a single line that could explain the variance, right? Because that's basically quadratic, right? So like you can't necessarily model it properly with a single line, right? But yeah, so I see that someone just changed the answer. Okay, yeah, but okay, good. I'm glad to see that most people got it right. Okay, so now I'm gonna move to the second question. I'm gonna activate it right now. Then I'm gonna go there to read with you guys. Where is it? Yeah, here. If you build a linear model again, right, such as y equal to a plus bx, which of the following error index best summarize the model performance? The options are mean absolute deviation, root mean square error, median absolute deviation, or I don't know. 4 answers. And very important, keep track of your own answers, right? So like how you're doing in this quick quiz. And if you realize that you're not doing great, right, or that you don't know most of the answers, reach out to us so we can try to help you with respect to like catching up in this background, okay? So that's for your own measurement, like so you can sense your own knowledge where it stands right now and seek for help before it is too late. Okay, so let's see the answers. All right, that one was pretty good. I see a lot of consistency there. So like people answer the root mean square error, right? Which is the only metric that actually takes in consideration 2 samples, right? Which is like the prediction versus the actual ground truth, right? Everything else takes in consideration the whole distribution. So like all the samples. So what's the deviation, right? When you're talking about deviation is how the single sample deviates from the mean, for example, or the median, which by no means could be used as a proxy for performance, right? So excellent, very good, guys. So now we move to the third one. And this one, I hope it's closer to what you guys usually do. Okay, so like hopefully you can see this little table that I'm providing here. So suppose I want to use machine learning to predict rainfall based on the following table. And here you see the table, right? The table consists of like a table of countries, regions, then the states, right, within those regions, the climate, and then you see latitude, longitude, and then the average annual rainfall in millimeters, okay? So I'm asking you here, so like, I hope you remember from what we discussed earlier today, right? That the observations usually consist of the samples, right? And the predictors or the features, they're the things that you're going to use to try to develop your model, right? So based on that, what do you think it's the observations and what do you think are the predictors here? We are already a little over time, but we are going to try to move fast. Excellent. Let's see the answers. Okay, the observation. Okay. Okay, so let's discuss this now, right? So I said that I want to predict rainfall, right? And so each observation has a desired outcome, right? Which is the ground truth, which is rainfall, correct? So the observation, in this case, it consists of the rows in this table. And I hope everyone, it's in the same page with respect to that, right? So this is the Y, right? So like each observation has its own Y. And then we can say that this is the X, which like that's the input that I'm going to provide, like the inputs here, right? And this is what I'm trying to predict. Okay. So yes, you can call the observation as being the rainfall, right? Although I would say that the observation is actually the rows, right? And how you name these rows, it's up to you. So for example, I would say that each sample consists of like a location that's coming from a state, right? And what you're trying to predict is the rainfall, and what you're going to use for that, which are like the predictors, right? Then could be everything in between, which is like the climate, the latitude, and the longitude, right? So I would accept both answers as correct at this point, which would be like both states, right? Which like the states, they determine what's the name of the observation, right? Or what's the actual rainfall that you're getting there. But like in machine learning, usually you say that's the name of the sample, not what you're trying to predict. That's the observation. So like most likely you're going to find in the literature that the state is actually the observation. Okay. And this is the why, or like what you're trying to predict associated to that observation. Okay. Any questions there before we move on?
Yes, can you explain that once again? Like what we're trying to predict are the predictors, right? And the observational are the things that we have previously, like the inputs.
So the observations, right, are the samples that you have. Let's start there, right? Okay. So what are the samples that you have for this case? Basically, they are defined as like some measuring stations that are located in those states. Good. So those are the samples that you have, right? Now, what you're trying to predict, right? You're trying to predict, let's say that you're building a regressor model to predict average rainfall. Good. Now, what you're going to use to make this prediction, right? Can you use the country? You could. Can you use the region? You could, but they're not going to be very informative. Like most likely what you need to make a good estimator, right, is going to be the latitude and the longitude, which basically tells exactly where in the map those stations are. So like they are more specific than country and region, right? And the state, it's basically a label. Like it's like, what's the name of that measuring station? Okay, so like those are the samples essentially. Is that clear?
Yeah. Thanks.
Okay. Yeah. And you see that I constantly keep switching back and forth between features and predictors because like people in my field, they call it features of a sample, right? But Pepe told me that like for people that do geocomputation in general, they're more familiarized with the word predictors instead. But yeah, they refer to the same thing. Let's move on for the sake of time, right? And everything else is going to be based on these same examples. So hopefully we're going to move faster, right? So now I'm asking you, is the prediction of rainfall a classification or a regression test? What do you guys think? It's a regression, it's a classification, both, neither, or I don't know. And for this, I'm going to give you 10 seconds to respond. And you should be able to respond immediately because I already gave the answer in the previous example. Okay. All right. So everyone thinks it's a regression. Very good. Because after all, it's like a real number, right? It's like a value. You don't really have a class here yet. Excellent. So like moving on to the next one. Now, suppose that you want to predict the climate, which is like the other column, right? Using the other predictors. Now the predictors are latitude, longitude, and the average rainfall. So you see that the problem changed now, right? Now I'm trying to use latitude, longitude, and average rainfall as the predictors, and I'm trying to predict the climate, right? Is that a regression, classification, both, or neither type of task?
I can't answer.
Oh, it's not active. So sorry. Yeah. Okay, 10 more seconds. Right, let's check the answers then. Now it's a classification task. Very good. Why is it a classification task? So earlier today in the lecture, I told you that the classification basically stands for having like categories, right? Or classes. And then you try to fit in each sample as belonging to a specific class. What are the classes here? The classes in this case would be tropical, tropical wet, subtropical, and that's it, right? So you have 3 classes in this case, right? And you expect that the features or the predictors, they might be enough information for you to classify each one of these measuring stations as being located in a place that has one of the types of this climate, right? Can it be subtropical and tropical wet at the same time? No. So that's essentially where the thing of like being supervised learning has to come in, because like each sample has to belong to just one group, right? Okay, moving on. One more question. I think that's the final one with respect to this table. So I told you before that we could use climate, right? But oh, wait a minute. Climate's a categorical variable, right? So like you see that like climate is not a number that I can just provide to the neuronal network. Can I use it as a predictor, and why? What do you guys think? No, you cannot, because categorical variables are not meant to be predictors. Depends, because some methods take categorical variables as inputs. Yes, you can just turn the categories into integers and then go with it, or you don't know. So sorry for going over time. I see that we already supposed to be ended, but like we're very close to the end. Let's see the answers.
No, it's fine. It's ending the 45, so it's fine.
Ah, okay. Yeah. So the majority of the people say depends. Some methods take categorical variables as inputs. That's fair. I personally, I don't work with any method that would take a categorical variable directly as an input, right? Like there are some methods that they are capable of doing so because they have built-in ways of translating categorical variables to one hot code encoding, one hot encoding. So for example, what those methods they'll do is basically to map each one of these categories to an integer, right? So even though you think you're fitting in a categorical variable, there is something behind the scene that's doing the work for you, okay? So like, I don't have any knowledge, and please, if you do know of any tool that will take directly a categorical variable, post in the chat, because I'm very curious to see what would be that.
Yeah, random forest can get, for example, categorical as a predictor, as it is, but probably
I checked
as you
today,
mentioned,
and I checked today, and it said no. You have
no,
to use
yes,
integer.
yes.
Yeah.
Yeah.
You
I
don't
mean,
need
as
to. Yeah.
Yeah, you have to label, for example, in R as a factor.
A factor?
As a factor, as a character, as a
Okay.
factor, but you can use it, yeah.
Okay. Well, neuronal networks, you cannot. You do
Probably
need
not,
to.
yeah.
Yeah, you do need to convert it to an integer. And yeah, I'm very surprised to see that random forest does it, because as far as I saw, apparently it doesn't.
Because it is working thresholding, you know, so it doesn't do bigger than and less than, but it say equal to A, do this, equal to B, do this.
Okay. Yeah, that's perhaps is the decision trees, right?
Yes,
Is
perfect.
it, yeah. But you can you build like a regressor out of it still?
No. So if you use as a response, it's going to be a classification.
No, not. I'm telling you about like using that as a variable, like as a predictor.
Yeah, as a predictor, yes. Inside to a regression, yes.
Okay.
Yeah.
Learned something here. Yeah. I don't use random forest for anything. So very good.
Okay.
Moving on then. So now I want to probe a little bit of your knowledge on Python. Okay. So I did this very quick example here, right? So basically what I'm doing is to use this NumPy library. And if you have done anything with respect to data analysis on Python, I'm pretty sure you use NumPy, right? So what I want to see is like what you believe would be the outcome. If I ask to print the value of A, right? What do you think would be the value of A? So it's just one operation that I'm doing here. And I would like you to the best of your knowledge, what you think is the outcome, just so I can see how familiar you are with like Python, to do math in Python. And if you don't know, please say, I don't know. If you do know, if you have any guess, choose between the options that you're seeing here.
Could you activate?
Activate.
Oh man, yeah, sorry. Yeah. And again, if you don't know, please reach out to us so we can help you. Okay. I'm gonna wait for it to get to 17. So I need one more person. Okay, 17. Very good. So the majority of the people do understand what this operation is doing. Okay, that's very good. Any questions? I don't think so, right? Like everyone apparently got the answer right. So let's just move on. So there is one more operation in Python that's very simple, like with respect to things that you're going to have to do in Python, right? Which basically to use for loops and conditional statements, right? So again, to the best of your knowledge, what do you think I'm going to get if I run this for loop? And I'm going to wait until 17 answers before we check the response. There we go. Response is going to be 4 and 5. The second most voted is 4. Okay, so like, let's review this statement, right? So I'm saying that I'm going to iterate like in this range, which is from 0 to up to 5. When I use range, it doesn't include the last number. So basically that means that I'm going to iterate from 0 to 4, correct? So the 5 is not included already, correct? So like these are open intervals. So like the actual numbers, the actual integers that are going to run over, they are like from 0 to 4 effectively, right? And then in the second line, I'm saying that I only want to print the index if it's greater than 3. So if this bounds me to the range from 0 to 4, and here I only print something if it's greater than 3. So the answer is that is only gonna print 4. Okay, that's a tricky one. So like but I see that like people didn't guess like outrageous things. So that's the sort of thing that you could very easily catch if you're implementing it. So that's also a good sign. I'm happy with it. Okay.
Hey, Antonio,
and now,
just to confirm, you said it's because Python is just 0 based, so that's why it didn't go up to 5 with the range.
Correct. So like if you say to MATLAB person how to count numbers, they start with 1, right? So it's 1, 2, 3. Python, what's the first number in the sequence is 0, 1, 2, 3, you know, and the last number is always open. So like you're saying that you're going to iterate up to 5, but doesn't include the 5 in this case. Good. Very good. So now to Longzus. So Longzu asks, do you like my presentation today? I'm going to activate. And then in this one, you should be able to just answer whatever you want there. So you can, but remember that this thing takes like single words. So if you actually want to write a sentence, you have to use underscore. Okay, we got one answer so far. Yes. I hope Longzu is overloaded with joy right now. Okay. Well, that was what I had planned for this session. I think I can turn back to you, Pepe, if you wanna.
Yes, thanks, Antonio, and thanks to all of you for replying to this question. It's going to giving us a very good base for starting in the teaching. So we come up over the class. So for next week, for Thursday. So be sure to have the virtual machine running properly. If you don't, please reaching to us by Slack. Let's try to solve the issues. So Antonio is going to help people if they have some issues with the Mac, because it's also using Mac, and Lonzo AI, we are going for the others. So if you have problem and you have time, you can even stay on the chat and we can try to solve it. So that's it for today.